The recording is started. I'll introduce you guys first. Hi everyone, welcome back to the bi-weekly Federated Learning Working Group meeting. So today we're very lucky to have Alex and Hassan telling us about MedPerf, which is an open benchmarking platform for medical AI. Medical AI has the potential to advance healthcare and improve lives across the world, but careful consideration needs to be taken into account during its product development lifecycle, with AI validation being an important phase for clinical translation. And this is basically the goal of evaluating AI platforms is basically the goal of ML Commons more broadly, which I'm sure everyone here is already familiar with. And MedPerf in particular is tackling the evaluation of medical AI models. So clearly there's a lot of overlap in interest, especially between MedPerf and MONAI. So we're very excited to have you guys here. And to introduce our speakers today, Alexandros Karagiris, sorry for butchering the pronunciation. Karagiris is the co-chair of the medical working group at ML Commons, a group aiming to develop best practices for benchmarking medical AI on real-world data to improve clinical translation of AI. Previously, he worked as a researcher at IBM and NIH. You must be glad to be out of NIH now. His research interests lie in the space of medical imaging, medical machine learning, and mobile health. He has contributed to healthcare commercial products and imaging solutions deployed in under-resourced area. His work has been published in peer-reviewed journals and conferences. Hassan Kassim is a machine learning researcher, machine learning engineer with a background in ML ops and federated learning. He's been working for more than 3 years in the fields of software engineering and AI. He also enjoys playing in his free time, playing chess and understanding psychology. Thanks so much for talking to us today.
Thank you so much, Sai, and thank you both, you and Holger, for this opportunity. I think we have, basically had a presentation a couple years ago before, I think, with the MONAI deploy, I believe, Micah, and we just want to give you some updates what we have done. I feel like there's more synergies in this context here with this working group, and today I'm gonna give a presentation a little bit about the ML Commons, so people can familiarize themselves. Then talk about MedPerf, and Hassan here, my colleague, is gonna give a demo, so people can see a little bit hands-on. And I think we can open the floor for basically Q&A, and maybe discuss next steps if there are any for potential synergies, collaborations. Right? We are both I know MONAI and also ML Commons, open community, open source, basically Apache tool, licensing. So, we have a lot of synergies here. So let me see if I can share my screen. So I have some, a few slides. I don't know if you can see my screen.
Yes, we can see.
Cool. So I have a few slides just to cover, basically like these concepts. Like I said, like you introduced, Sai, we're going to be talking about, MedPerf, which is an open, platform for federated benchmarking. And here you can see some of the names in the leadership. We have a lot of, participation from, academia as well as, the industry, because, the organization is fundamentally built on that. And a little bit about the organization before I jump to the MedPerf. So what is ML Commons? ML Commons is an association of companies, technology companies. And you can see here, different logos. These are members of the association. For those who are savvy with IRS codes, this is a 501c6. So it's a members organization. But there's also strong participation by the academia, right? And the organization started back in 2020 officially as a benchmarking organization to measure the speed of machine learning workloads on accelerators. That's why you see a lot of, I would say, hardware companies on these logos, right? But the I would say the North Star, what guides us as an organization is this quote by Peter Drucker. For those who don't know, he's a famous economist, business professor in Chicago, which basically brings down everything into one score that what gets measured can be improved, right? And if you think about benchmarking is exactly that. It helps align different areas of the industry, intra within the companies or organizations, and across basically organizations, and align them basically to form between research and development, and also different areas of the industry, right? And brings everybody to focus on kind of improving, whatever underlying technology they're looking in. In this particular, space, we're looking, basically how to improve AI. Um, so the organization is, functioning similar to what MONAI is. We have working groups focusing again on benchmarking in different areas, from MLPerf, which is basically to measure the speed of workloads on different accelerators, to the AI risk and responsibility working group that focuses on measuring the safety of AI LLMs, this big foundational models. There's also a data sets working group that tries to release data sets for different benchmarking purposes. Our working group, which is a medical working group, and then we're going to talk about it. And there's also other working groups like the Hassan, which is a metadata format for machine learning data sets. And this has been adopted by Google, Hugging Face, Kaggle, that helps basically with the development of AI models as well. These are open, groups. Anyone can join. And again, all of them, if you see, from left to right, are focused on, developing best practices around benchmarking, tools like MedPerf, for example, or datasets. And the idea is like, going back to this quote from Peter Drucker, by benchmarking, we have a score, we have metrics, and that helps, drive innovation in AI world. That's our basically process. Um, so within the medical working group, like I said, there's different participants and contributors. Over the past 3 years since the inception of the working group, we had participation, and we had participation either as an advisory members, or engineering resources with engineering contributions from different organizations, including NVIDIA here. And what we basically been maintaining and developing is MedPerf. Like Saim, you mentioned, which is an open benchmarking platform. And because this goes back to when we kick it off 3 years ago in the working group, we all know, we are all familiar, of all these, stories, AI being developed in the labs, validated in a small, scale, limited data sets. And we've seen, stories like that, that when people take it to the real world, there are, some small, big, large, failures, right? So when we started, this, working group, we wanted to, focus on how to make a validation, of AI in the medical world more, like I would say, robust. And that's why we want to, bring the notion of, real world benchmarking, right? Where, you test, the technology in a more diverse, real world data. So through, basically this collaborative, effort with participation of all these, players, we set out, to develop MedPerf, which basically more or less is like a federated evaluation, right? So you have a frozen model of frozen models, and you try to evaluate them against diverse datasets. And similar to basically to the notion of federated learning, you transfer basically the model to the data providers, and you evaluate locally, you benchmark locally. And that, as we know here in this working group you're very familiar with, it alleviates a lot of the privacy concerns around the data sets, right? Um, One key thing I want to highlight in our implementation, and you'll see it also from the demonstration later, we try to integrate a human in the loop. And we're doing this for accountability and transparency purposes. So every time there's some sort of, basically approval or rejection of an action, there's a human in the loop to, approve or reject. For example, when, there's a request to run the benchmark in a particular, data provider, then, the data provider, has to accept or reject the benchmark. So it's not fully automated. And the reason, again, we could automate this, but we intentionally leave it, to the humans to, approve or reject, So for those, so fundamentally, at a high level, as a design philosophy, uh, we believe, that, meaningful, impactful benchmarks should be driven by diverse committees. Uh, you can feel, the benchmark committee is like the ultimate authority that designs the benchmark. And when it comes to, the medical world, you can think, these, benchmark committees having memberships, members or, representation from regulators, from, healthcare organizations like healthcare providers, or, clinicians, could be pathologists, it could be, surgeons, whatever, the notion, the scope of the benchmark is, right? And also you have participation from model, developers as well, what we call here model owners. And, the benchmark committee ultimately is responsible for authoring, the benchmark and specifying the policies. And when we say, a benchmark at the end of the day is basically some script, like an implementation in Python, let's put it, this way, and that, pre-processes the data according to, the specifications of, the benchmark. So basically, if you normalize, standardize, the data set across different, data providers, it has, maybe a post-processing after the model runs, after the inference, to kind of, create, any um, um, consolidation, aggregation of, the results. And of course, it has, the metrics. So the benchmark, committee needs to define, those metrics, right? What are you trying to measure? And you can think, these benchmark committees could be focused on particular areas. It could be, let's say, around digital pathology. It could be around radiology, or it could be a more, granular, right? Focused on a particular area of, disease or condition, right? Also, the benchmark committee is responsible to recruit data owners and model owners, and of course, create, these assets that I described, and who gets access to the results, right? So I'm gonna skip a little bit quickly here. Like I said, in this hypothetical example here, to visually see the benchmark committee recruits, the healthcare organizations and they want to participate in a particular, benchmark. Same thing with, the AI developers, reach out to, the AI developers, and then MedPerf facilitates, orchestrates basically the execution of the benchmark. So basically moving, the AI models to the data providers, running the benchmark, locally, aggregating, by the results and sending them back to, the MedPerf, leaderboard, if you will, for so that, the benchmark committee can disseminate, the results. And as you can imagine, that's something, we all are familiar with, evaluation and validation. You give, access to different stakeholders, some added value, if you will. Right? So, for example, with, the AI researchers, you can test the performance in real world, settings. You can potentially, monitor the performance. The healthcare providers, they are able to identify potential, systems out there for procurement, or, test, different AI systems. Patients come back to the benchmark committee. They can participate in the benchmark committee and, drive the discussion and also the development of the benchmark, and kind of, highlight areas or metrics that affect, basically the patient outcomes, right? So at the end of the day, all these AI systems should, basically serve patient populations, right? And for regulators, you can, utilize an open infrastructure, right, to be able to test, the technologies. And we are kind of, like I said, no, I didn't say that. We're kind of, trying to work with the FDA on a particular project that, they can use for real world, benchmarking in digital pathology. I'm gonna skip this. Hassan can provide more input on the technical implementation and also demo it. But more or less, MedPerf has two components. The MedPerf server, which is basically a registry of benchmarks, metadata of the raw data. So we're not storing any patient data, right? We only store in description of the data, so metadata information. Same with the models. We don't host models. The models can be hosted Hugging Face or wherever, private or public, or GitHub. Again, we don't host the weights, and the results could be stored whatever the benchmark committee wishes to for. So we allow this basically decentralization of the assets, right? And then I would say the core component of MedPerf is the client, which allows the participants, either the model owners or data owners, to utilize it and register their assets, either the models or the data. And of course, like we all know here, we're AI researchers, 85% of the work is in the data preparation. So we have also some tools to help with the data preparation and the data preparation and the pipeline of the data operation, so that the benchmark committee can monitor the preparation status across all the participating organizations. And once they pass some sanity checks, then they can submit basically for a registration of their dataset to the MedPerf and to the benchmark, so that the dataset can be utilized further for benchmark execution. And we have also, web UIs for easier for users to be able to navigate. We're still, basically, in the I would say the alpha version of the web UI, but I think Hassan is gonna demo that as well. Now, what we have done so far. Our group, through this participation of different members, have extensive background in federated learning, federated settings, and currently over the past more, I would say, year, we've been supporting a neuro-oncology federation of 51 hospitals across the world, with which is it's a study that is commissioned by Indiana University, Duke University, and the response assessment for oncology working group, which for those who don't know are basically the working group that sets the standards for neuro-oncology, and they want to basically evaluate AI models on federated fashion, so they can see if it's AI could be useful for assessing post-treatment of neuro-oncology patients. And I think we should have some the final results in the summer. So we're aiming for some publication. We try to be as a group very transparent. So if you go to our webpage, you'll see a lot of reports with technical reports describing pitfalls, challenges, as well wins, like what we were successful at. And of course, we want to have participation from different experts in the healthcare industry, data owners, AI researchers, because like you guys here, you want to have this input and collaborative environment to be able to build better tools. So yeah, that's more or less from my end. I'll pass to Hassan, and Hassan can give a little bit more, I would say, in-depth technical description through a little bit of a demo. I recommend that we wait for Hassan to finish, and maybe we can take some questions, so we have a clear, basically, flow of the presentation.
All right. Yeah, thanks, Alex. I'm gonna share my screen. share. Okay. All right. So yeah, first a few words about the MedPerf components. Just a recap before I start the demo. So yeah, MedPerf consists of a MedPerf server. You can see my full screen, right, of the slides.
Yes.
All right. So there is the MedPerf server, which is it's hosted. It's now we have a central MedPerf server hosted by ML Commons, and this will store the registries, dataset metadata, benchmarks, model metadata, results, and this server. Well, if there is an organization that wants to use MedPerf and they want to host their own MedPerf server, their own registries, they can easily host their own MedPerf server somewhere, and then they configure the MedPerf clients easily to communicate with a specific server. This is for the MedPerf server, and we have a client application in Python. This will, usually the users, whether they are data owners, benchmark committee, or model owners, they will install the MedPerf client and use it on their own machines. And the MedPerf client comes with two user interfaces. We have the command line interface, and we have also, a fresh feature in MedPerf, the web UI interface. I'm going now to demo the web UI. And as Alex mentioned, using the MedPerf client, all users can do the required actions to conduct a benchmarking, experiment from the start to the end. And so now, before I, do the demo, a quick overview of the players, during a benchmarking experiment from the start to end, and the actions in a high-level way, the actions that will happen during the benchmarking experiment lifetime. So we have, three main roles. There's the benchmark committee, which define the benchmarking experiment, goal, purpose, the assets for data preparation, evaluation, and so on. We have data owners, which for example, a hospital, clinical center that own medical data, and we have a model owners, which are companies, users that have AI algorithms, and they want to benchmark it. So those are the three main players. They communicate with the MedPerf server. And the first step in a benchmarking experiment is that the benchmark committee will define three main components of a benchmark workflow. The data preparation, so how data preparation executes. Basically, what I mean here by they define means that they define the code, right, that do data preparation. This code will take raw data and transform it into a prepared version of the data that is ready to be consumed by an AI model. This includes pre-processing, and this also includes some other. So we have a standard about writing data preparation. I'm going to talk about it, in a few minutes. So the second component of a benchmark workflow is the reference model, or basic in general, it's the model inference, right? So the benchmark committee will define a reference model that serves two purposes. First, it serves the how this model expects the input structure of the prepared data, and how does it output the predictions. So this reference model will define also what is the structure of the predictions generated by a model. And then we have the third and last component, which is the metrics. The metrics code, which will take the predictions generated by a model and the ground truth labels from the prepared data and generate metrics results. Those are the three components of a benchmark workflow in our MedPerf convention. So first, the benchmark committee defined those pieces of code. Then, as a second step, and then data owners, after they offline, there is communication from the benchmark committee. For example, the benchmark committee has a document, has a website, makes a call, hosts a website that says we need data owners to participate and model owners to participate. So this is how a data owner can hear about the benchmark. Now, if they want to participate in this benchmark, they register their raw data and it prepares this data set according to the data preparation logic from the benchmark. And then, okay, and the data preparation, in MedPerf, we have it, in a standard way that it should do 3 tasks. So data preparation is composed of 3 tasks. First, the preparation, the pre-processing, which transforms the raw data into a data format ready for consumption by the model. There is the sanity check. So we have a way. So we have a placeholder that the benchmark committee should define as checks on the prepared version of the dataset. This is to ensure to minimize errors and to ensure the data is of good quality. So this sanity check logic is defined also by the benchmark committee. And there is also the third step during preparation, which is the statistics. So in benchmarking, in addition to the performance results, statistics of the data can be valuable. And so the benchmark committee also defines a statistics portion of code, and this piece of code will generate statistics of the data sets, such as number of cases, number of records, number of classes, etc. So after preparation is finished, the third step is for the data owner to request participation to this benchmark. Because in MedPerf, we have a notion of, it's like a friendship request between a benchmark and a dataset. So in order for this dataset to be considered a part of a benchmark experiment, they have to request participation with this benchmark. So this, they send a request to the MedPerf server for that. And during this request of participation, a compatibility test will be run on the client side, of course, on the data owner's machine. A compatibility test will be run to make sure that this data set format, okay, is compatible with the benchmark components, which means the reference model and the metrics. So the results of this compatibility test will be also sent to the MedPerf server as a part of this participation request. Now, this is data owner's side, the phase of preparation. Now let's, from the model owner's side, there is a model owner who wants to submit a model. The step is to register this model in MedPerf, okay? And there is a step here to wrap this model in a certain standard container standard. And after that, they register this model to the MedPerf server, and they also request participation with the benchmark, with the target benchmark. And this is similar to the participation request from the data side. It's like a friendship request between the model and the benchmark. They request this participation, and as part of this, there is a compatibility test that will be run between the model and those components. And after this, the sixth step is the benchmark committee will approve participants or reject them. So they will approve, for example, data owner's participation and approve model participation. After this, now the data owner can run the benchmark. So they click, they will click a button, and all models associated and approved by this benchmark will be automatically downloaded to the data owner's machine and will be run on the dataset in the data owner's machine. And after that, after the execution happens, and what I mean by run benchmark here is that the models are run on the datasets to generate prediction, and then the predictions will be used by the metrics code component to generate results, performance results of the models on the dataset. And then those results will be submitted by the data owner to the MedPerf server. And those results will be visible to the benchmark only. They are not public. So this is these are basically the steps from start to end. Now I'm going to run the demo. Okay. So we have here the web UI. Okay. A user would run the web UI here. It is a command line. Okay. So the web UI runs basically as a server on the local host, of course, only. And for a better security check, we do. So this is the web UI. Okay. And we have a token here in the command line, so that it's like a better security check, so that it prevents access of other Linux users on the same machine, for example. So now they are in the as a user, I'm in the web UI, the MedPerf web UI. This is all local, right? This web UI is local. Okay, so now I'm going to play the roles of each one. Okay, so first I'm going to play the role of the benchmark, then the model, then the dataset. All right. So first I'm going to log in as a benchmark owner. So this is a tutorial, right? And as a part of this tutorial, I'm communicating now with the local MedPerf server. I'm not communicating with the actual central MedPerf server. And also the authentication system is mocked here, right? Because it's a local server. I already have 3 users: benchmark owner, model owner, and dataset owner. All right, I'm gonna log in with those. This is only mocked authentication. For the real MedPerf server, it works, all right? But now for the tutorial sake, it's local. Everything is local here. So I'm going to log in as the benchmark owner. Okay, I'm using as mocked users here locally. This is the email of the benchmark owner, BO. So log in. Okay, and after login, now as a benchmark owner, I want to create my benchmark. All right, and submit it to the MedPerf server. We have an option to test the benchmark workflow before submission. As I said before, the workflow contains data preparation, reference model, and metrics. So, imagine you are a benchmark owner, okay, an actual benchmark owner. You have those codes somewhere. Before submission to the MedPerf server, it would be better to test their compatibility before submitting them to the MedPerf server. I'm going to skip this step because of the time, to make sure I finish earlier for questions. Okay, but usually this is the way to test a benchmark workflow, and here we locate the components of the benchmark. Data preparation. Oh, by the way, when you see the word MLCube, just treat it as a container, right? We used to use the MLCube the MLCube software developed by a working group in ML Commons. This is like an abstract interface between multiple container technologies, for example, Docker, Singularity, etc. Okay, so when you see MLCube, just consider it a container, like a Docker container. So here we locate it. We put the path to the data preparation container, the reference model, and the evaluator. And also, there is one other component for testing of a benchmark, which is the demo dataset. So this component, it's similar, it serves similar goals of a reference model. Reference model is used just for compatibility testing, right? And for defining the how should the structure of predictions and of input data should be. The demo dataset as well is just a mock, it could be a mock data, but preferably it should be a public data. It could be just one or two images. And the purpose of this dataset, this demo dataset, is just to be able to run a compatibility test with new models, right, that want to be a part of the benchmark. So that the model, before being really a part of the benchmark, the code compatibility can be tested for the benchmark workflow. So here also we provide the demo dataset data path and labels path, and you run the workflow. All right, but I'm gonna skip this now because of time. So after running the workflow and make sure it works, now one can register a benchmark. And to register a benchmark, all right, you need benchmark name, description, a URL for the demo dataset. So the demo dataset, which is this mock public dataset for testing, it should be hosted somewhere. So here you should put the URL, and then you should put here the data preparation ML cube. This is a typo, all right? Data preparation ML cube, reference model ML cube, and evaluator ML cube, all right? Which are the three main components of the benchmark. And so you should first submit those ML cubes to the MedPerf server, all right, before submitting the benchmark. So we click on ML cubes and we register a new ML cube, all right. First, let's register the data preparation ML cube. So I have, in our documentation, I already have the needed URLs, right? So because this is a tutorial, we already have everything hosted, right? So as a benchmark owner, you first need to host the code, the container of the data preparation, all right? Everything is already hosted now for the tutorial purposes. Okay, so for the data preparation container, usually a container in MedPerf has multiple components. So first, there is a manifest file, all right, which defines the image, the container image of this container, of this code, all right. There is also a parameters file, which is an optional one, which this will be later, when it's run, this file will be mounted to the container. So this is just for, as a better practice of not hard coding some parameters in a container code, one can have a parameters file, which will be mounted to the container. And we also have another optional component of a container in MedPerf, which is additional files, all right? And these additional files may contain any other needed assets for the container to run. Mainly, it's the model weights. So also we try to make it, to encourage users to do better practices of not hard coding or putting the weights inside the container. So weights can be hosted separately, and then during runtime, MedPerf will mount those weights to the container. So now for the we want to register the preparation ML cube. So these are the assets. We have the manifest file. We'll put it here. The name, let's just name it just X-ray prep, because in the tutorial here I'm running a benchmark about just X-ray classification. All right. And we have the parameters file, which is here. It's hosted also. So we put those. We don't have an additional file for the preparation cube. We submit. And now it's now being submitted to the MedPerf server. Again, we only submit metadata. We don't submit any actual code to the MedPerf server. Now, after this, it's now submitted on the MedPerf server. Here is the page of this container. This is the name, and we have here, it's some fields like, so as you see, we only store the link to the manifest file. We don't store actually manifest file or parameters. We host links, metadata. And later during runtime, the MedPerf client will download those and run them automatically. And now let's register the reference model ML cube of the benchmark. Right. So let's call it just XRF. This is the manifest file. This is the parameters file. And here we have an additional file which contains the weights of this reference model. Submit. All right. And now let's register the evaluator container, right? Which is here. There is the manifest file is here. The name, let's call it just X-ray eval, and the parameters file is here. And submit. Okay, now we have our three containers, which are the main components of the benchmark, submitted to the MedPerf server, right? And as you can see, when we click on the ML Cubes page, we have three, right? This is the evaluator, this is the reference model, this is the preparation. And they have now, if you enter the preparation, it has now an ID. This ID is from the MedPerf server. Now we can register the benchmark. So let's go to the benchmark, register a new benchmark. Let's call it just X-ray 1. Description, anything. Right. The demo dataset URL, we already have it hosted. All right, it's here. The data preparation model, I already have memorized the IDs of those. So it will be, the ID of this one is 1. For this one, it's 2. And the ID of this one is 3. Those are the needed information for registering a new benchmark. And now we click submit. Now, the MedPerf client will usually, retrieve those ML cubes, right? Because we have links, right? Link of the manifest file and parameters file. So it first makes sure everything is downloadable of the correct standard or structure. And it also runs the compatibility between those. So if you remember the step I skipped, which is the compatibility test. So before submission of the benchmark, the MedPerf client will automatically run this compatibility test before the submission. Now we have the benchmark submitted to the MedPerf server. This is the information about the benchmark. Again, it's metadata. And as you can see here, it's now pending. What I mean by pending is we have a small, policy now in our MedPerf server, which is we need a MedPerf server admin approval for a new benchmark. This can be easily removed if someone wants to host their own MedPerf server and remove this policy. But now the benchmark to be later usable and for data owners to use its preparation logic, it has to be approved by an admin from MedPerf. And I have now here just this is as a user shouldn't worry about this, right? I have a script here that will do this automatically. Okay, so now refresh and it's approved. All right, so this, as a benchmark owner, this is mainly what they have to do. Okay, plus the approvals, which will come in later, approving the participation. Now let me log out and log in as the data owner.
I just trying to intervene here. We have only a few minutes, so
yeah,
I think it's worth jumping into the other two roles. But now what Hassan demonstrated was basically the benchmark committee, the benchmark owner, what we call registering on the data, the model, the benchmark itself, and then the other two roles. I don't know if we want to continue this, or what do you think, Sai?
Maybe we could. I think what is most interesting to the working group might be to understand how the data sets are defined for the evaluation. Yeah, or actually, maybe we can pause first if anyone in the working group has any questions
Yeah, let's
they
do
would
that.
like
Let's
to
do that
ask,
because
and then maybe we can continue with
yeah,
the
shoot
presentation.
the question.
Does anyone in the group have questions about MedPerf or um, yeah, I'm sort of curious about how because this is a federated platform. How do you ensure that the data sets across the different participants are comparable, up to standard, it meets the evaluation criteria? Because presumably there's MedPerf seems to need to convince both the data providers as well as the model owners that this is legitimate. I guess to convince the data owners, yeah, I'm curious to hear your
Right.
thoughts on
Yeah.
this
All right.
process. And
Do you guys want me to answer that or?
Oh, yeah, Mike,
Sure. Yeah, so the gist of it is there's not like some sort of well-defined standard for it. We intend to adopt such standards as they come into being, but instead what it is that the preparation logic itself is hashed, contains checks, contains measurements, contains validations, and the data set that's registered essentially gets tagged with the hash identities of the algorithms that have tested and checked it. So the standard is literally defined as the hash of the container. That's the ID for the standard. So it's de facto. And what that arises from our practice, which is just that, for example, on the FETS initiative, we ended up just adding tools to this set of logic that was running as we found more and more ways that things were not aligned or correct, right? It's not like we knew ahead of time exactly what to check for. We found out after the fact about different kinds of ways in which the data could go wrong. And so then with MedPerf, essentially what you do is you're going to take best practice, you're going to capture all those best practices in a container, and you're going to tag it with that. And we intend to actually add pipelines for this where you can be tagged with multiple tests that you passed. But for right now, there's this monolithic, I am the standard container. It's literally just the code defines the standard because there's not really a better way we know of at the moment, but there are other efforts toward this end that will have more of a formal definition that we hope to adopt. And I think Alex can talk to some of that that's going on in ML Commons better than I can.
Right. And then just, to add to what Michael was saying, I think, aside you're alluding to the quality assurance, right? So how, this data is yes, and I guess, we try to include some, I would say best practices. And these are, best practices are more or less driven by the community. So for, the this particular project we're working with Indiana University and, Duke, which is the FETs that, Michael was was talking about. We try to include some sort of, quality assurance using, maybe some, pre-trained models that are able to identify, specific, regions in, in these images. And if they don't, exist in annotations, then, you fail and you mark them, you flag them. So there's a whole other part of, this that you don't see. And it's the data preparation pipeline that we built for, the medical imaging. And that, creates it has a lot of stages from the annotation part to
Yeah.
the quality assurance. And yes, there's no magic bullet. This is all driven by its use case, right?
Yeah, 80% of the time is spent in the data preparation for any federation with manual annotation, right? And the logic, even I would say, there's most of the logic written for the experiment is in the data preparation and analysis.
That's fascinating. Is that part? So one of the I'm not sure if Holger already mentioned this, but one of the things we're really interested in looking at is sort of this is really hard work, and this is sort of very domain specific and needs a lot of expertise. What the FL, like the MONAI FL working group is trying to do is try pull in these understandings from the community, and so that others can reuse, because this is extremely hard-earned knowledge which the
Exactly.
FEDS team has.
Exactly. Yeah.
Yeah, it would be wonderful to learn more. Maybe you can give me a pointer, or we can set up like another meeting maybe with
I think we should
Alex.
follow up this one.
Yeah.
I mean, Michael, because I feel like, the data
Oh,
preparation, pipeline by itself that we built, for Feds, that by itself is the best practice that, Asai is alluding to, right?
Yeah.
Yes, exactly.
And I feel like, we can, synergize there and even, integrate with MONAI or,
Yeah,
figure out some
exactly.
other method, because that's a valuable tool for, the community, right?
We want
Yeah.
our platform to be flexible enough that it doesn't really so much matter whether it was implemented using MONAI libraries or something from DKSZ or whatever it might be. It's it's of some family of community libraries that we know how to integrate. The same goes for MONAI deploy versus MLCube. Alex alluded to our conversation with them. A lot of why that didn't really go forward is was like, great, when the time comes, we'll work together. We're just not there yet. Right, but it makes total sense for us to be able to launch a MONAI deploy package, right?
Exactly.
No problem.
I see there's a raised hand. Maybe Ahmed, you can go ahead.
Yeah, hi, thanks. Thanks for the presentation today. Very nice work. Just have a question regarding the data owners, right? So the assumption is that you assume these data owners have enough compute to really run these models, right? So what would be the case if these data owners really doesn't have the compute? They have the data that they collected or pre-processed, but they don't have the really enough compute to run the model. What would be the case?
So right now, the data owner user is really the computer operator that has access to the data. So it's kind of a collision of roles merged into one. So in the scenarios where they don't actually have it, they literally, the person that they delegate to run the compute out of band is the one who registers as data owner, right? You can think of it almost custodian.
I think we lost Micah.
Yeah.
Oh,
Micah?
sorry. Am I back?
We can hear you, but
It's
can't
just
see you.
completely lost. You can hear me, but can't see. Yeah, my camera just went out, and now you're hearing me through my computer instead of my headset. I have no idea what happened. Okay, sorry about that. I'll have to fix that after the call. The gist of it is that we're working on a framework that has a little bit better separation between the compute operator and the actual owner and decision maker, and in fact other roles beyond that, and the ability to delegate more cleanly, and including delegate between institutions, right? But that starts to get into a platform and framework that is a bit beyond the size of our development team. So we're really looking to help define what that should look like, the policies that should guide it, and then essentially integrate it with other existing platforms beyond just MedPerf.
Nice.
Because when you get into those kinds of scenarios where you have complex ownership relationships and complex decision making, it needs probably there needs to be industry implementers involved. Frankly, it just gets to be a considerably more complex platform.
Right.
Okay, thanks.
Yeah, I guess we can, like, maybe Holger and I can reach out once to set up like one more meeting to see where we can sort of merge efforts and transfer some capabilities between the implementations.
That would be great, yeah.
Yeah, definitely. It sounds like we need to continue the conversation. Yeah, thanks very much for showing your platform. That was really interesting.
Thank you, my guys, for the opportunity. We appreciate it. Yeah. Looking forward for the follow-up.
Yeah.
Okay.
It's good to see you all.
Thanks, everyone. Bye.
Bye. Thank you.
Thanks.
Bye.